Yeah, thanks for this opportunity to speak about what we're working on. We're all volunteering for the Open Air Cloud Association. So, what is AR Cloud? Um, I had to go and ask DALI 3 if it understands what this concept is. And apparently, maybe I did some good prompt engineering. But you see here, we see the AR is in the city scale. We see points of interest. So we see 3D objects. And hopefully, this is going to be very useful and beneficial for the people down there in the real world. Next slide. Let me see. There we go. In the GIS world, we often think about maps as these layered concepts. The old traditional maps, they tended to be about the static world. And in this figure here, that intends to describe the spatial web, you have the physical world, the 3D, the atoms, as the static layers. Then you might have some more recent advances in technology allowing for real-time maps of maybe digital twins moving around with geoposes that you can represent as kind of a new reality map layer. And when you connect to the physical world, then you allow for this rich set of thematic layers that you can attach to the real world. They might represent something that is there or something that is entirely digital. Next slide. So the next slide thing is oh, we jumped over here. And we could play this. This gives an example. You jump to 33 seconds in if you can do that. Okay. Okay. Let's not
I
do
think
that.
we're going to go back to this one.
Yeah. Um, let's skip this video. So the point of that previous slide was showing how these kind of static map layers allows for all these dynamic things where we have multiple people interacting with the physical world and you have digital content in that physical world. That was 4 years ago, that video, and it was not based on any standards. And we're all here because we're working on standards. And for something that is kind of this comprehensive as an AR cloud ecosystem, we want to take inspiration from something that has demonstrated work. And Gob, can you mute yourself? I hear a lot of noise. Um,
Okay, we hear you okay.
okay,
Is there a microphone that's open somewhere in the room? I don't think so.
someone
Yeah,
called
it is
Gob.
yours. It's a room microphone.
Yeah, I think
Oh,
it's
okay. That's the thing. Okay. Yeah, so this has scaled tremendously, become like the foundation for the modern world. We have a small set of standards, protocols. Oh, everything jumped here. What happened? Okay, we're back. Yeah, we have this set of standards and protocols that prove to scale very well. So taking inspiration for this, we can take the next slide. This is an open web platform. So we imagine that we can kind of expand on that concept to create an open spatial web platform. Next slide. This is an old slide back from 2019. Yeah, 19. We presented the first ideas for the open spatial computing platform. And in this slide, you would see the standards, protocols, and the services and the client side. This is kind of like a mirror of the web, but for spatial computing. And you see something there, GeoPose. It's all through the platform. It should also be on the client, but it's not in this figure. But every part of this platform requires GeoPose. And that wasn't a standard back then. So this was proposed for OGC, and now we have this standard. Yeah, next slide. Let's walk through this platform, how it works. We have the spatial clients, and they have some ways of connecting through to the cloud side. So you could send over your course location, then you get a lot of spatial services back in return from a spatial service discovery system. Now you can ask for a GeoPose, sending you some images, maybe some other sensor data to a visual positioning service. Now you have obtained your GeoPost in the real world. You can use that again to ask for more services in the real world. You can also stream your GeoPost up to services and subscribe to other kinds of things. Next slide. One very essential thing is to find and discover content around where you are. And these sets of contents can be associated with GeoPose, whether they are 3D objects or they're kind of points of interest. And we can demonstrate both later. Next slide, or next, yeah. Obviously, you leverage the traditional web technologies to download the content to your client. Next slide. And yeah, so here you kind of see how you have this client server structure. You have spatial services. They are more decentralized, closer to where you are, with data that is relevant in your spatial context. And you have these devices out there in the real world that can leverage this. Next slide. Yeah, and we did, those of you who have read the standard, you might know that there are 8 encoding targets. We wanted to make this platform of ours very easy to use, so we're keeping it simple. So we actually only use the basic quaternion GeoPose targets in our platform. So over to our friends. Thank you.
Thank you, Jean-Eric. I think now we're going to continue. Wait a minute, we're going to switch to Gabor's presentation. And
I
he
should
has
also share the link in the chat.
conveniently put the link in the chat. How perfect is that? Thank you, Gabor. Do you want me to mute? I think I will mute ourselves over here so that there's less noise and echo.
Thank you. Yes, good. Okay, so for those who don't know me, I'm a researcher in Nokia Bell Labs, but I'm also a member of the OpenAir Cloud and one of the developers. And I will present you a WebXR client that we keep developing for many years now, and we added interesting OGC relevant stuff. There's a little bit of overlap with what we have shown in the Delft meeting, but there's also a lot of new things. And today we will actually show 3 different new clients. And one of them is this WebXR client. The other ones come afterwards. So Jan-Erik touched on this vision of the AR cloud. There's a nice picture also found online yeah, the idea is about geolocated digital contents. These contents can be anything, videos, even applications that others can discover at a space, and they are pinned to these locations. The contents are usually like freely available for anyone, and the contents are created collaboratively. And to make this happen, we need a very precise localization of the client devices. This is today only possible with visual localization, and making these visual localization maps is also a huge effort. So only like very big companies like Google can afford it. But I think in the future, this will be something that collaboratively maintained, these maps through open protocols. Okay, so in the conference, or next to the conference venue in this street in Montreal, we actually mapped the street with one of these VPS providers called Augmented City. This is how the point cloud looks overlaid on OpenStreetMap. Basically, you have to download a smartphone app, collect a bunch of photos. From those, a 3D model is created, and this is geo-registered with the world. And when you send in a query image, you can localize the image in the point cloud, and through the point cloud, we can get the geolocation of the camera. This is represented as a GeoPose. And we thank here Rosie Chen from OGC, who actually captured on site. We can go to the next slide, please. If you don't have a VPS service in your neighborhood, but you still want to try this out, there is a fallback for just using the sensors, but of course it's not as accurate. This is just a side note for those who want to try it at home. We can go to the next slide. We also recently created a web tool to pin contents to certain geolocations, specifying a GeoPose and the URL to, let's say, a 3D model. A new content type is small icons, but we can also extend this later with point clouds and other types of contents. All contents are public by default, and currently the database is hosted at the Rutgers University in New Jersey. These are some examples of the contents that I created around their office here. So primitive models that are created from text, descriptions, 3D model, points of interest, context-aware content. I will talk about this later, and the GeoPose stream, which is a new thing that I want to present in the next time. Can you please jump? Yeah. So this is what you would see in this WebXR application if you go in front of the conference venue. So we placed here a couple of points of interest, the hotel next door, and some icons of the participating companies over the windows. This is just to hint at what is possible today, but yeah, many ways to there are many ways to extend this. So what happens here is basically following the open spatial computing platform working principles. So first, there's a discovery of services in the neighborhood. Then from the list of services, we select a visual positioning service, which is Augmented City. We localize with it, and then we go to one of the content services, knowing the geopose of the camera, and we retrieve all these contents. And in addition, we also retrieve a message broker service, which is in my demos, is a MQTT or RabbitMQ server where you can subscribe to specific topics and send messages, geoposes of agents. Yeah, the local tracking happens with the WebXR, and we align the local coordinate system of the AR session with the geolocations, with the geocoordinate system using the reply from Augmented City. Okay, next slide, please. We showed this in Delft last time. This is about points of OGC point of interest in front of our office. I wonder why the video is not playing. Can you please click on it? I set it to auto, but yeah. So what happens here is I start the AR session running in Android Chrome. I point towards this facade, I press localize, a query is sent to Augmented City, I get back the geopose, and then I go to the content services, I retrieve all these points of interest, like cafes, restaurants, and the entrance of our office. So if everything is good, then these POIs should actually arrive where they are in reality. And we can even have a height, so this is one of our nice meeting rooms up there. Okay, we can go to the next slide. And we also did a conformance test with a different application, MyGeoverse. You will hear more about this from a coming speaker. So you can create a POI on the fly with one of the applications, and then you can discover them in our WebXR application. There is a video here, but I will not show that, just the screenshots. And this is the most interesting part. So I implemented the GeoPose streams. Here we have multiple robots and multiple smartphones in this room. They localize in the point cloud of the room, and then they basically align all their local coordinate systems with the room or with the world. And then they, through this RabbitMQ message broker, they can actually share their geoposes with each other. So every agent knows where the other agents are. Now, on a smartphone, you can actually click on the floor. So what we can do is you can calculate what is the geocoordinate, the geopose of the click on the floor, and I send that over to the robot. The robot decodes it and then converts it to its two-dimensional LiDAR map. It plans a path and then sends that path back, again, as geocoordinate or geoposes, an array of geoposes, to all the other clients. So the smartphone can then visualize in 3D, this line, how the robot is going to move in the future. So you can actually, this is a very powerful way to use AR to show something that is invisible, what will happen in the future. You see that I put my leg into the path, and then the robot keeps replanning the path, and then shares always continuously the new replanned path. So I think this is a really interesting demo how powerful it is. if we can share GeoPose streams. On the bottom part, there is also a screenshot that there is a point cloud representation of the room where we can also see these paths. And because everything is represented as GeoPose, it would be possible to show it in OpenStreetMap. I forgot to capture that as a screenshot, but we could also see the path on OpenStreetMap. Okay, we can go to the last slide. And this was created by Mikael Salazar and in Norway. This is a location-based generated content. So based on where you are on Earth and what are your preferences, let's say a couple of important big cities in the world are shown where they are, and you can even add a new one. And this content is always generated based on the information of your current GeoPose. So I think this was interesting. Okay, that's all from my side, and we can jump to the other clients. So this was the WebXR client. Everything is open source, so if you want to try, just contact us. There we can provide you the links. It's in the OpenAir Cloud GitHub.
Cool, thank you, Gabor. That was very well timed, just perfect timing. So now I'm going to try to go back to where we were. Yes, I can do this. I'm navigating it now, and I'm going to go here and put it into slideshow. Wait a minute. There we go. Thank you, Ali. Can you hear us, Ali?
Yes, I can.
Okay,
Can you
so yes, we hear you. Thank you. Go ahead.
This is Ali Hantal. I am CEO of XR Masters and a governing board member of Open Air Cloud Association. Next slide, please. I'm currently going to talk about the demo that we have done in Delft and a little bit more than that, and what Gabor has done with the WebXR client. Actually, now we'll be talking about two other clients, and all of the content that you're going to see on this demo will be provided by MyGeoverse platform, which actually also has a client app called MyGeoverse mobile app, and that app can actually localize with different methods, including augmented city, Google VPS, GPS, and other ways. Next slide, please. Purpose of the demonstration is actually we want to illustrate how various augmented reality clients can can visualize geospatially anchored content using the GeoPose standard and the point of interest standard, which is under development. Next slide, please. You have seen before how the OSCP structure works, and in this demo, there are three apps, and two of them, including the WebXR Sparkle and XR Masters MyGeoverse, works with a VPS client. And on the right side, you can see that scheme is happening, and first, there is a spatial service discovery system. The services discovered, then the MyGeoverse goes and gets a GeoPose estimate from augmented city, and then there is now the spatial content discovery happening on the right, and then the host, the content is being downloaded and rendered on the position. And on the left side, what we have done with Ether Explorer is Ether localizes against a QR code, and that QR code has an encoded GeoPose. So what we do is we actually get MyGeoverse client localize and get its GeoPose at the position where we are going to hang the QR code. So this way we are equalizing the systems, and now when Ether Explorer gets localized against the QR code, it now is on the same coordinate system, and then it can go and skip the VPS steps and get the discover the spatial content around it, and then downloads and renders it. So this is what we have added to the demo. As you would know from last demo in Delft, there were only two involved. That was XR Masters MyGeoverse and the Sparkle. Now there is a third one. Next slide, please. And now there is a third one. So a VPS service provider, Augmented City, is involved, which is an OpenAir Cloud member. Then a content publishing platform, which is the MyGeoverse spatial content management platform, another OpenAir Cloud member, and 3 spatial browsers, namely Sparkle, MyGeoverse, and Ether Explorer, which also is a member of OpenAir Cloud. Next slide, please. Here, as this is the same slide I explained already, but how the demo works. More. Next slide, please.
Yeah, Ali, we're running a little short on time, so I'm gonna tell people that I will meet them outside during the lunch break, and happy to show. Nazi's got the Android, the Sparkle client. I've got the iPhone showing the 2 other components. It's just right outside.
Yeah, let's switch to the video so that everyone can see to the end, right, Christine? Just the video after this. This shows how. Yeah, this is how it works actually, and now we can be done in 1 minute. This is my GeoPose localizing against the point cloud, and there are POIs around it that are already placed, front POI, right POI, left POI, and what you can see after this is this exact demo. I'm now creating a POI. This was in Houston. I say behind for this POI, and once I create the POI, I go ahead and now place a GLB OGC logo right next to it and put it a little bit higher than that. So once this is placed, now I can go back and open Ether Explorer app, which I'm doing right now. And there is a QR code, has an encoded GeoPose already that we have manually set before. So looking at that QR code, Ether Explorer now localized and can visualize the content I just placed there, and also the ones that are placed before. This was the addition to the demo we did in Delft. Thank you very much.